Alrighty then. Hello, hello. Let's get the old audio levels going here. What's going on, everyone? Let's get rid of that one. So, how's it going? Today we're gonna do a little bit of coding of things. We can start the game here. I'm gonna I'm gonna load into the level just without any sort of missions or anything going on. Just the raw level. And we can have a leisurely drive around this place. So the more I spend time decorating this place, the more I add places where the vehicle can get stuck, where the player can get stuck. Let's see if we can find one such place somewhere. You can see we have some newly decorated places here. It's not quite done yet, but getting there. Hello, Nick. Yeah. You can have the demo immediately when it is done. Yeah, I'll probably organize some sort of early access, not early access as in early access, but some sort of like early play testing for the demo before the demo is sort of available as just a general download. I'll probably organize some sort of early, what should I call it? I hate to call it early access because it's not the early access that people know and love, or know and hate. But yeah, what I'm basically trying to say is that I'm sure there'll be some way to get this demo even before it's done. Once it is in a shape where I don't have to be embarrassed for it anymore. I'm trying to find some place here where I can get stuck. Of course, when you try to find something like that, you always have a hard time finding such a place. But basically, I've been having some of my family members play through this demo lately, because I've done some mission scripting for the demo mission. Just to make sure that it can actually be, played through. Right, so here you can see. And they've been getting stuck like this quite a few times. I kind of know what not to do to avoid getting stuck. But you can still get yourself stuck well and good quite easily. It's kind of nice these days because when you have the radio system, you can call one of the other vehicles to you and basically use them to help you get unstuck. Like the easiest way to do that is quite simply if you have a scout vehicle, for example, you just you ask the mother to come to you if you're in a place where they can do that, and if all goes well, the mother vehicle will drive up to you and you can just switch to it and then just like nudge the scout vehicle a little bit to basically get you unstuck. So that's kind of handy. But you don't always have that option. And of course it might take some time for the mother vehicle to reach you and so on and so on. So we need to create a system that basically lets you get unstuck if you are stuck. Where's my mouse cursor? There it is. And I figured we'll start working on that today, actually. Yeah, you can see we have some new areas here. Or not necessarily new areas, but newly decorated areas. Of course, these are kind of dominated by these cliffs that are still very much white box. But it's kind of coming together, slowly but surely. The elevator has also gotten a facelift, and it is also fully functional now. You can actually play through the demo now, as of like a couple of days ago, without using any sort of development hacks or anything like that. So that's nice. Still some changes I want to make to it though, but it's pretty nice. And it like brings you back to the main menu and all of that. It has like the full flow there in place. So I spec'd out a system that I thought we would try to implement in today's stream. So the Unstuckifier, as it is called, at least on like a technical level. So this is not necessarily going to be like a gameplay feature in its current form. The Unstuckifier is really just like a system that a gameplay feature can then use to get unstuck. And so what I'm imagining here is like a component that we stick on these vehicles that we might want to get unstuck. And that component records transforms, so the position and the orientation at like even points, even distance between them. Yeah, when the vehicles move far enough, record a new point. And distance between these points can be given as a blueprint property. And we store a certain number of them in a ring buffer. And yeah, just debug drawing them to make sure that they work kind of nice. This is sort of like the first step. Just create a component that does that. And it has like a state, it's either it's enabled or it's not. And when it is disabled, it basically records where the vehicle has been. But yeah, this comment here is basically like this is not like a gameplay system in itself, because you're not necessarily supposed to be able to enable this Unstuckifier at just about any point during the game. There might be some restrictions to how that actually works. But before we can get to that level, we need to actually have a system that we can actually just use to get unstuck. And when the system is enabled, it does not record any new points. It just uses the ones that it has already. So it selects the target point, and then it tries to move the vehicle towards it. So if you're driving and then you get stuck on like a rock or something like that. There's a rock over here. Like this, and you get stuck on this, like, and you can't get out. It's tricky to get stuck when you actually want to get stuck, right? You never get stuck when you need to. You just get stuck when you. Well, I'm kind of actually stuck now, except I can't get out. But anyway, this system would now have recorded points along this path that the vehicle sort of took, and when you enable it, it tries to actually move you towards those points if possible. There might be some edge cases that we need to handle. Like if you are over here, for example. Let's pretend you're stuck now and you've sort of driven over this rock. Like the previous point might be sort of here like on top of the rock. It might not be possible to just move you there in a straight line. But we'll see. We'll start with that and then we'll see what happens. So it starts with the most recent point, and when the vehicle is close enough to that, it goes to the second point. So you can sort of like almost think of this as like a rewind. And we apply a force at the center of the mass. And if the vehicle has no recorded points, or it comes close enough to the last recorded point, the system just automatically deactivates. So you can just like rewind along a very long path. And yeah, then this is just an idea that I had. We'll see if this actually works out. So the magnitude of the force is proportional to the linear velocity of the vehicle. When the linear velocity of the vehicle is 0, the max force is applied. And when it's approaching some target value, then no force is applied. So I'm hoping that will, regardless of the mass of the vehicle, that should allow us to, like, you know, get moving again, essentially. I like the Halo-esque style. Thank you. Thank you. Halo is indeed an inspiration for this. Absolutely. The whole Warthog driving feeling. It's kind of like why this vehicle is sort of like pretty sort of bouncy and very sort of physics-driven, physical in that sense. So I'm glad it evokes those feelings. Right. Yeah, both the max force and the target linear velocity can be given as blueprint properties because they probably need to be tweaked still for each vehicle. And then I had some questions here, like what do we do when deactivating the system? Do we just clear the history, or do we start from scratch? And do we need to apply some torque as well? I don't know. Maybe. Maybe we do. But that should basically allow us to, like, I'm hoping it will be a system that's kind of difficult to abuse to like a very high degree, you know, because you can't use it to like teleport into new places. You can only use it to go back to places you've already been, because it's recording the places that you've actually visited. And if we apply some restrictions on sort of how you can activate it, how often it can be activated, how long it can be active for, all of that, it should be really useful to just get out of a tricky situation, but not like make it so that you can just teleport across the map. So we'll see. But I think we'll start by simply creating that component. And that should get us on a good path. So, let's go here to game object components, just add I'm gonna call this the unstuckifier component. Unstuckifier component. Zig. Unsuckifier component. Oh no. That's not good. Unsuckifier. Oh Jesus, I'm having a hard time typing now. Unsuckifier would also be good because it would make the game better by having it not suck. Alright. Do you have any tips on building an engine from scratch? I've been wanting to get into graphics, but I'm struggling motivating myself enough to learn Vulkan. I probably have a lot of tips on building an engine, but it's kind of a broad topic, so you would have to probably be more specific regarding something. I can say regarding the Vulkan thing, like don't start with Vulkan. Vulkan is not really a good graphics API if you want to stay motivated and building your own engine. that might upset some people, but that's like something I truly believe. Start building your engine and use like a pre-existing graphics package for that, which you can then later rip out and replace with your own low-level Vulkan renderer or whatever you want. But just start building the engine and don't stress about Vulkan, because it's Vulkan is kind of not really for people. It's for I don't know who Vulkan is for, to be really. Would it be better to start with SDL 2 or 3? Maybe. I'm not sure about the rendering capabilities that come with SDL. I was thinking more like, you know, start with like BGFX or even Ogre or something like that. And just get like the graphics going. Just, you know, get enough graphics going that you can start building a game with it, and then like flesh out the engine around that. That is what I would do. Build all the other things that the game needs from the engine, and then if you're not motivated to build like a renderer from scratch using Vulkan or DirectX or something, then just don't do that. You know, keep it abstracted to such a degree that you can, if you later want to replace it with your own renderer, then you can do that. And just start building the rest of the engine, and that is what I would suggest that you do. Alright, so I think I have a ring buffer. Let's see. Basis. Ring buffer. Yes. So, right, this is basis ring buffer, so I don't really need to like shorten it anyway. I can instead just do like what do we actually store here? We have something called a physics. Let's see. Like a physics transform, I think. Yeah, so this is a position and an orientation. This is exactly what we want. So I'm just gonna move it here. And then we're gonna put in here like a, we can make it public, yeah, sure. So transform buffer, probably. And that would be like a basis ring buffer of physics transforms. And now we need to give it a size. Well, 8. 8 should be enough, I think. We don't want to record like a whole bunch of it's not like the idea here is not that you should be able to just like drive somewhere and then just rewind across the map, and that won't work anyway, because won't be able to like move the car in the exact same way that it was traveling. That's not what we're even trying to do here. So I think 8 will be fine. And what we actually want to probably do next is get the blueprint properties going, because that will actually drive quite a few things here. Thanks for the advice. I will do that. Great. I wish you good luck. Have you mostly switched to Zig from C++? The game is Zig. The engine is C++. There's a whole bunch more C++ code in this project than there is Zig code. So I wouldn't say that I've switched to Zig from C++. I just I like writing gameplay code in Zig. So I switched to writing gameplay code in Zig, but the engine is still C++, and I still semi-regularly write C++. Like I wrote some C++ yesterday for the engine, for example. But yeah, the game is Zig. The game is Zig in the same sense that a Unity game is C#, if that makes sense. But yeah, that's just personal preference, really. I like Sig for writing gameplay stuff. Cool. I don't think we will need message received function. We will probably need tick. We might actually even need a pre-tick. I'm thinking we will probably need a pre-tick. So pre-tick runs before. Maybe I even have a. Yeah, I have a snippet for it here. Pre-tick runs before the physics. The physics update. Tick runs after the physics update. Hello, Wookie, welcome back. Update runs every variable rate update of the game. We most likely won't need this, but I'm going to keep it around for now because this is useful if we want to debug draw the positions. So that's really handy. Let's go with that. But let's look at something that has some blueprint properties. And for that, I'm going to go to the data. I'm going to go to metadata. And here we have all the game components that have blueprint properties. Maybe like this one. That's more like it, I think. So what we do here is we create a new UIDEF file. Unstuckifier component. And we just give it the name of the, basically this registration name here. Like this. Because I had here in my spec some notes about wanting to actually put some of these values in a blueprint property right away. So distance between the recorded points. That would be one thing. So recorded point distance. That would be a float. Default can be like, I don't know, maybe like 1. I typically keep my JSON names. What is this? What is that? This is snake case. What is this? This is like mixed case? I don't remember the name of this. Yeah, record point distance. I mean, these things don't really matter all that much. If I'm lazy, I just do this. Explicit default value is true. Yeah, we'll want that to be true. We actually only want these to be floats. So we have that. And then we have like we have the max force and we have the target linear velocity. So target linear velocity. So the target linear velocity is the thing where you are like, okay, I want to get unstuck now. And the system has a target linear velocity, which is like, okay, let's try to get the thing moving. And the target linear velocity is like how fast it tries to get basically the vehicle to move. So let's just put this in as well. Something like this. You don't even have to give all of these things, but I typically do. So this would be like in meters per second, right? So what is a good so if we have like 10 kilometers per hour, that would be like 2.7. So let's have like 3. Target linear velocity is 3 meters per second. That would make it 10.11 kilometers per hour, which is like I don't know how many miles per hour. Probably like around 10. And then we have the max force. That's a float. Max force. like so. An explicit default value just means like if we don't change these, they still get put into the JSON data, so the component can read them from there. So it's a pretty good thing to have. Was that it? I think so. Yeah. So now if we just go in and we register this component immediately. On Stuckifier, typically just I publicly declare them here in this components zig file, and then I need to put them here in the list so that they actually get properly registered. We can build this. And now we should be able to go into the game object type and actually add one of these guys to the scout, basically. Let's see, yeah, Eagle blueprints. So let's put one of these guys here. And now, since we actually created this, take those things away. Since we actually created this UI definition here, let's make sure that's saved. Should be able to find it here in this list. Reload UI definitions. It helps if you save the file. No? Okay. Oh, I have something running here. Oh, I don't. Yeah, I had the preview running. Right, now that succeeded. And this is saved. Let's open that again. Let's see if that helps. Oh, that's the problem. Trigger area component. That's not the correct. It's not the correct name at all. There we go. And then we need to give it a name suggestion. So just like Unstuckifier. It basically only needs to live on the server, I think. But maybe it can live on the client as well. Let's keep it on the client. That's fine. Yeah. Yeah, it's probably fine. Right, so now we go here. Right, the com radio component. Now we should be able to find the Unstuckifier right there. Okay, and here we can see the recorded point distance, target linear velocity, and max force. The max force, I have no freaking idea how large that should be. It should probably be larger than 1, but yeah, let's keep it at 1 for now. That's fine. Now this guy already has this component, so that's fine. And I'll just unload that to not block the DLL while we're writing this code here. So this guy needs some state. It needs an active boolean, which defaults to false. It needs to have one of these transform buffers. So transform buffer. And I think we can probably initialize it like that. Can we? Don't remember. I think this thing actually has like a... Okay. Can't actually do that. What does this thing have? It has just an init function. Okay. Yeah, this is a little stupid. I mean, I'm initializing everything here, but basically I could just do this right here. That would maybe be easier, but let's just go. Transform buffer is transform buffer.init. Whatever. Like so. Yeah, I'll just keep that without any initializer at all. So now then, we need to create a blueprint properties object to be able to actually read like these values. So let's see. I'm just going to copy paste it from some other component here if I can find one. Thing like the means vehicle probably has one at least. Yes, blueprint properties. So just bring that over to the side. So there's a little bit of zig comp time magic going on here, where like if you have a field called blueprint properties, which is an optional pointer to or optional const pointer to something, it will assume that something is a blueprint properties object, and it will create one for you. So let's just get the name of this guy and call it unstackifier component properties, like so. Allocator, right? We need to just do allocator is std mem allocator. So now this guy will get one of these unstackifier component properties objects assigned to this guy, and it will load the JSON that is produced by those three values. So we better actually just have them here, otherwise it's gonna get confused. We don't actually need that, but we need the UI definition of. So we have these JSON names here: recorded point distance, target linear velocity, and max force. It will assume those things will actually be found in the JSON data, and actually have those exact names. So I'm gonna do like F32. Just copy pasting them out of that UI definition, like that. And in this case, since this is so simple, quite often I have to like massage these things a little bit to have them actually work out. I need to actually initialize these guys here. In this case, I don't have to do basically anything because these are just quite simply, we can get rid of the D in it completely. These are just three floats. I can quite simply do self and then just assign these three guys here. Max force, like that. That should build and be quite all right. Alright, now then, basically I think in tick, this is where we want to record the points. So if you're like self, not active, right? To do record points. In pre-tick is where we are like if we are active, so we can get rid of that as well. If self-active. This is like the place where we want to apply the force, etc. So I want to apply before the physics tick has happened, and we want to record after the physics tick has happened. think that makes sense. And here we can probably just do a very straightforward for. Well, actually, let's get rid of that self again there. For self dot transform buffer. Right, this doesn't have like a really like an like an iterator or anything that we can iterate over, but okay, we can do it like this instead. We can do, actually we can probably do transform buffer. We can do actually 0 dot dot self transform buffer get count, right? And then we get an index out of it, and then we do basis debug draw sphere, where the center is self transform buffer get. Right, so get back returns the newest element in the list. Doesn't really matter. We basically want this offset. We can get it from the front or from the back. I'm just gonna get it from the front, maybe towards the back. I think that is sort of more sensible somehow. The radius would be like 0.5 maybe, and the color can just be like basis color white. So now it will basically draw all the positions that it has recorded, if that makes sense. What's going on? Oh, right. We need the position out of that. So, position. Yes, like so. And I actually want to format this vertically. Yeah, that looks good. All right, so now we need to basically record the points over here. We don't have a way to actually activate this guy yet, but it doesn't, or well, I should say that that's really not a problem at all, because we specifically don't want it to activate yet, because we want to record the points. But basically we want to have a last recorded position, which is going to be a basis math vector 3. Let's shorten that a little bit. Come up here, do vec3. And we can just initialize this to like a vec3.0 or something. Probably be actually reset to something like really large. Let's create a reset function here for ourselves. I'm gonna do like a private section here, so do like a, actually it doesn't need to be private, it can be I think public, if you want to have someone else come in and reset this thing. So this would be like self dot last recorded position is vec3 init, and then basis math large number, basically for all the components. So basically that means that whatever threshold we have, distance between the points, it's gonna be, it's gonna consider it. Okay, it's time to record a new point now. That's kind of the idea. And if we call reset, then we'll probably want to actually clear this as well. Clear the transform buffer, like so. And now then, in tick here, we can just do, we can assert that we, let's do like an S assert, so we have get a source location here if we need to. Self blueprint properties is not null. Actually, let's do that on object created, and then after that we can quite simply use that. BP props self blueprint props dot question mark, and here we need to get the transform of the vehicle, right? So let's do const probably like world matrix, or we can get the orientation positioned separately. Maybe that's actually what I want, because I want the orientation as a quaternion. I mean, I can get it from the matrix. I can convert it into a quaternion, but this is maybe easier. So position would be self.context.transform.get world. No, get position. Thank you. And then we have the orientation is the same thing. Get orientation. Actually, we don't need to get that quite yet. We need to check if it is time to actually record a position. So let's do distance, and let's do a distance squared. And we'll take the position, and we'll subtract the self dot last recorded position, and we'll take the squared length. And if you're wondering why we take the squared length, then we don't have to do a square root, which is just quite simply faster. So if you're like comparing distances, you should generally use square distances instead. They're just cheaper to calculate. So if distance squared is larger than or equal to, and then we have this, actually it's BP props dot recorded point distance, but we can do this, we can do dist threshold squared, be something like that. So if we have moved enough that we want to record a new position, then we quite simply assign that last recorded position, and this is now where we want to take the orientation. So let's get that guy, and we'll do like self transform buffer pushback, and we'll do physics transform position is pos and orientation is ori. What is my editor doing there? Right, something like that, maybe. This should now already give us some interesting points on the screen if we now drive around with the vehicle, I bet. Let's see what we have. Let's put in some launch parameters here so that we don't have to go through the menus all the time. Right, so you can see some stupid things here. As we are falling down, we actually get our position recorded, but now it's kind of, we get this sort of weird looking tail following us. And we can make that tail just as long or as short as we want. We can add in 32 just for shits and giggles. And we can make the distance a bit longer. So let's do like a, just to make sure that this actually works, right? Let's make that like 3. And we play the game again. So we should now have 32 instead of 8. And there should be more distance between the points, and that looks like it is working. And then when we reach 32, it will start erasing the oldest one. So that's nice. Now this is way too long for this unstuckifier, of course, but it's fun to play around with it, maybe. Weird looking cart tail. Immediately I want to just play with this and mess around. You just get a visualization of where you've been in the world. But anyway, now that we have this, we can start moving the car back along the path it has taken, so that's handy. And I think actually the one world unit distance between those points is probably good. If we have it at 1 though, they should be close enough to touch each other. Do they actually do that? Yes. So you can see they just about touch each other, and that is of course because we are drawing the. You can see that it kind of depends on how quickly we were moving. If you're moving slowly enough, then between one tick and another, it will basically have time to record. If you go faster, then there probably won't be. So you can see that you get a little bit of space between them, but that's fine. That is completely fine. So there's like a question of like how long do we actually want this to be, right? If you're driving, I think this vehicle's top speed is like 120 kilometers per hour. So it's actually quite fast. So there is always the possibility that you sort of like you've gotten yourself stuck by like driving fast off a cliff, and you basically just want to like rewind back up that to the top of the cliff. But this is pretty long, so I don't think I'll want to have it quite this long. But yeah, we'll see. We'll see. Now then, I'll bring that down to like. Actually, I'll leave it at 32 for now. It's handy to have it quite long for development. So applying the forces, let's look at the spec we had here. Like record transforms, that's done. So it can be sort of enabled and disabled from code, and we should probably just map some button to it for now, so we can just toggle it on and off. And I wonder, like, I think basically the way we have this set up is that it uses the linear velocity of the vehicle to determine if we have sort of moved, if we have gotten ourselves unstuck. And so that means that if you're driving at like 120 kilometers per hour and then you suddenly activate it, well, first of all, you're obviously not stuck then, but if you do that, then it will immediately turn it back off again, because it will go like, okay, well, that's fine, you're moving. Or actually, it's not. It's it will not actually turn it off, but it will apply no force. If we're following this rule that like the magnitude of the force, the unstuckifying force, is proportional to the linear velocity. And then the linear velocity is like 3 meters per second, as we had input here, which is like around 10 kilometers per hour. If you're driving at 120 kilometers per hour, you're obviously above that. So that would mean that this rule then is applied. So no force is applied, basically. So I think we actually want like a fourth value here, which is basically like the maximum linear velocity that the vehicle can have if you want to activate it. Otherwise it just won't activate, and it will actually be, it'll be kind of small, but not quite zero, because you can quite often you can get stuck on a rock and you can sort of like wiggle the car a little bit, but you can't get, you know, out of the place that you're currently in. Oh, I'm remembering now that I set a rule for myself that this should actually be in kilometers per hour, so we need to actually convert that into meters per second. Blah, 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 blah. Trying to remember where's that conversion. How does that conversion go? It's like either divided by 3.6 or times 3.6, depending on which way I want to go. But it's probably actually divided by 3.6, right? Let's see. Where's my Python? There we go. So you have 10 kilometers per hour divided by 3.6. Yeah. So let's actually get that done. So target velocity divided by 3.6. So convert from kilometers per hour to meters per second. So all the code, the code always works with meters per second when talking about velocities, but the input is always kilometers per hour. That's sort of my standard for this sort of thing. All right. Oh yeah, maybe we'll actually, maybe we'll do like, should we just like hard code that threshold there, or should we actually, so that's like some fly flying in front of me here. It's basically like this target linear velocity. We have something like activation velocity threshold or something like that. And actually, maybe we want to call that just speed, you know, activation speed threshold. So if you are driving, you know, faster than, or yeah, if you're driving faster than 10 kilometers per hour, is still probably too high. Let's make that like 5. I'll just do the same thing for this. If you're driving faster than 5 kilometers per hour, you can't activate the unstuckifier because you're clearly not, you know, stuck. maybe I actually want to put the unit here to remind myself that that is what it is. Let's put it in the description instead. Let's write some better descriptions here for this. The distance between the recorded points. Put that there after all. The linear velocity the unstockifier is aiming to reach. Right, something like that. The max force applied to the vehicle to get it unstuck. And then activation only possible if the vehicle speed is lower than this. Something like that. Then I need to copy this guy into our properties struct here. So props dot and that should also be converted to meters per second. Cool. And with that, I think we might want to not have these as I think we might want to actually put like an underscore here. So this is how I typically, something that I'm sort of trying out. I'm not sure if this is actually how I'm going to do it in the end, but if I have some members here that I don't want the user to just poke at willy-nilly, but rather use through some sort of setter, I put an underscore before it. So like this. There's one as well. And there's one as well. And then we'll put in like an activate or deactivate function here, which checks that threshold and all of that. Right, that needs to be underscore. I don't quite follow this rule like everywhere, but in many places. It's just like, obviously it doesn't prevent anyone from just poking at these guys directly, but it's sort of a signal to the programmer looking at it, basically just me in the future, that oh okay, I didn't intend for anyone to just poke at these guys directly. I'd rather use some sort of public API to do it. So right, we have a reset method here. Now we can just do a public activate. Void. Something's gonna happen there. Actually, get a self auto fix there, so that's fine. And then deactivate. Should be like set active. Set active, and then we'll take in like active bool. Is that easier? Maybe that's easier. So with this we can check the speed of the vehicle, from the transform, or we can just use the the vehicle system for that. Maybe we'll just use the transform for that. So if we have let's see, const physics actor, get blah 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 blah, transform, get physics actor from here, and then from the physics actor we can get the linear velocity. Yes, so let's do like linvel squared again. We want to compare, so we can use a squared, and we'll do physics actor get linear velocity length squared. So if actually here we want to basically check you know, if active and not self dot active. So if we are trying to activate it, this is where we actually want to check this. So if linvel squared is smaller than that BP props stuff, we can again get this guy here. So BP props dot activation speed threshold, we need to again square that. Let's just output something here. Activated the unstockifier. We don't actually even need it to be an F. There's no formatting. So self active true. If the speed is too high, let's print that as well. Speed too high for the unstockifier. Something like that. Else if you know, active, not active. Do we actually need to check that at all? Maybe it can just be an else. Can it just be an else? I think it can. Well, technically, if it is already active and we call set active, then it shouldn't do anything. Maybe we'll use it. Keep it this way. Activated the unstockifier. And we can just print the thing here as well. Deactivated the unstockifier. And I think this is basically the API that this guy needs. Now we just need some way to actually enable and disable it. And I think I actually kind of changed my mind about this creation policy here. Let's have it only on the server for now. That should be quite enough. The server is the authoritative one anyway. If you move it on the server, it will get corrected on the client, so it's fine. It just means that it can never, like, either we need to sync it, that can be done in many different ways, but if we just keep it on one side, we don't have to really worry about that sort of thing. So I think it's just easier this way. But let's hook this into the input system. So I think I'm just gonna come up with some bogus input here. So like, let's see, what do we have? What do we have? Vehicle camera interaction, driving. Maybe it's like it's almost like a vehicle reset, which I apparently had previously. Let's do like vehicle get unstuck. Right. I think that makes perfect sense. We need to register it. So it's an action. Yeah, get unstuck. So we add it here to context. Not const, context.add input. And this would be input id dot vehicle get unstuck. And it is of type action. And then we can map it to something. Yeah, so driving controls. It makes sense for it to be in driving controls, I assume. So what do we have? Do we have some handy button here available for us? I'm just gonna add it to the keyboard for now. Have to sort of consider these gameplay implications later with time. So input ID vehicle get unstuck. Let's just map it to key U for unstuck, right? Yeah, I should really just go through and just remove these key code things here. Have just dot key space, dot key D, dot key A, etc. Nah. It's there right now, it's probably fine. So now that you're driving, you hit the U key on the keyboard. This action fires. That should be fine. And then we just need to actually hook that into the activation. That can be done probably in the vehicle avatar component, I think is probably the best place. So the avatar is sort of like the game object in the world that represents a player. So if you want to read the input, you typically want to do it somewhere in a component which is an avatar tracking component, like the vehicle avatar is. Because the avatar tracking system allows you to, first of all, you can ask it, hey, who is my game object currently, or who is the game object of this player, and or which game object is my avatar, and all of that. But it also allows you to read input, because like input is obviously handled like per player in like a multiplayer game. That would at least be the case. In a single player game, doesn't really make any difference, but it's handled through the same system. So as some components here, means vehicle component, for example, we can just put the unstuckifier here as well. Const unstuck. We'll get an auto completion here for it. Unstuckifier component. And then we need to basically keep this as an optional pointer to one of those guys. So optional pointer to an unstuckifier component, which we set to null. So not all vehicles necessarily need to have this. I mean, I guess in practice they all will. I don't think there's any reason not to have it, but currently we have it only on the one, so let's take that into consideration here, and we can quite simply do this. We can do self.unstuckifier component would be game object. Nope. Get component unstuckifier component. The big U. And then we can here in the pre-tick, for example, can read input. What does this do? Right, so we can read input if we are the client local avatar, or if we are on the server and the avatar host is not -1. So basically, like if we are on the server and this object is some player's avatar. Right. So now we can quite simply do if self unstuckifier component. And get a pointer out of that. So that will be true on the server with Scout, and all other cases it will be false. So it will be null, so this if will not execute. If self context get input action means input ID vehicle get unstuck. Right. And then we can just do comp active. No. Set active. Should be like a toggle active. Maybe it should be a toggle active. I'm gonna do like fn toggle active. Since I don't know exactly how this thing is going to be used, I'll just do it like this now, so that we can test this out. So set active, like not self active, right? So if it's not active, then we activate it, and vice versa. So comp toggle active. Yeah. Let's see. Oh, missing field. All right. So that would be because we added this guy here, activation speed threshold, but we haven't actually saved this yet with the new value. So if we save that, that should now fix it for us. Let's have a look. Yes. Good. Okay, so the output that we print now should appear here. So we can just do, yeah, if I press U here, it tells me like, speed too high for the unstuckifier. Oh no, oh no, oh no. Oh, still too high. Yeah, it needs to be activated the unstuckifier, deactivated the unstuckifier. Alright, that's handy. We don't see any spheres though. And that would be because we're running the server on a different thread. So let's just take that thing out and now we should see them again. So you can only debug draw on the server if you are actually on the main thread. So I'm just running on the main thread. Did I not do that? Oh, yeah, it needs to be actually set specifically to false. There we go. All right. So now we have the spheres appearing there, and now if we move slowly enough, so below 5 kilometers per hour now, and I activate that, it stops drawing those because now it is technically active. And now if I press U again, it will go back to drawing them. So that is exactly what we want. Excellent, excellent. Let's leave those outputs there for now, at least. So basically we have this thing left to do. Apply the force, etc. That one I can take out. I don't think I need it. I don't necessarily think I need the create one either, so we can just actually replace it with something like that and then comment it out. I tend to keep those in as just commented out things so that I can just uncomment them if I need to. These are things that the engine calls if you have it. Have them here, but they need to be exactly this this signature. But on object created is good enough for us. And I think I probably actually want to assert that we have the blueprint properties as the very first thing. Okay, so apply the force. What was the idea I had here? Let's see. Unstack is enabled and disabled from code. That's now done. When the system is enabled, it does not record any new points. Yes. Right, so it selects a target point which it tries to move the vehicle towards. Starts with the most recent point. And when the vehicle is close enough to it, it selects the next point as the target point. Applies the force at the center of mass of the vehicle. Yeah, I'm actually probably just going to apply it at the position currently. I think so. If the vehicle has no recorded points or the vehicle comes close enough to the last point, the system is deactivated. That's fine. And then the magnitude is proportional to the linear velocity of the vehicle. That sounds good. So this should all be relatively easy to do. So since when it is active, it's no longer recording points. What we can do here is use the indices, or rather like the offsets in the ring buffer as the target value basically. So this guy has get an element, offset elements from the front element. The offset is towards the back. Actually, we probably want it the other way around, like the front, no, the back offset. Right? Get back offset, yes. So get an element offsets element from the back element. The offset is towards the front. Exactly. Yeah. So back offset is this. This is what we want to use. So when we're pushing things into the ring buffer, basically you have like a how should I do this? Let's create some commented out area here for us to draw on. You have like a point here, so this would be the first point, then you have a second point, third, fourth, and so on. And this would be like at the 0th offset from the back. So the 0th point is the newest point. This is what we actually want to move towards. And then when we get close to it, we start moving towards that one. If that makes sense. I think it makes sense. So basically we will want to start with the target point index set to 0 and check if we are close enough to that to move to the next point. So there's again sort of like a distance that we want to compare against something, and I wonder if we need to maybe have that in the blueprint properties as well. Let's keep it here for now. I'm gonna add a new constant here called point switch distance, and we'll call that or we'll set that to 0.5 if the vehicle is closer than this to the target point, move to the next. And that might not be necessarily the correct value for that. At least for like for all vehicles. Maybe we'll actually want that, make that higher. Let's make that like 1. So that means that we'll actually probably just skip past the first point almost immediately, but that's fine. At least for now. All right. Yeah. All right, so then we'll want to have a target point index usize. Initialize it to 0. So this is like let's actually add a new line here so we can comment this properly. 0 is like the newest point. 1, 2, etc. goes towards the oldest. Right. So when we activate this thing here in set active, we set that to set self.active to true, and we set target point index to 0, i.e. the newest point. Actually, we need to have some points in the buffer to be able to activate it. So let's do like let's actually just check it here. If self transform buffer count is 0, then we just return. I can print something here as well. There's no point in actually there's no point in actually activating it if we don't have any points there recorded. All right, that's good. So apply force, etc. Let's see where is let's do like a const dist to target point, again squared, and yeah, let's do one step at a time. Target transform, that would be self transform buffer get, and now it's like it's back offset, was it? Offset toward the front. Yeah, I think that's, I can never remember this, which one goes towards the front. Back. Yes, the back is the newest element added to the list, so back offset 0 would be the newest. Exactly. Good. And maybe actually in tick is where we want to switch, do we? Now if this is active, check if we want to switch target points or deactivate. So this is basically, it's actually here that I want to do this. Target transform. Oh, actually I need it, yeah, I need it here as well. Never mind me. Yeah, I need it here, and then I need to do like target point distance. This can be squared, so that would be self context transform get position and sub target transform dot position length squared length, and if target point distance squared, if this is like smaller than BP props. Oh, it's not actually BP props, it was here in the point switch distance, that one. Like so. Close enough to switch points, right? You know what I'm thinking here, that what we actually want to record is not necessarily just the position and orientation of the vehicle at that point, but also sort of like the direction the vehicle was heading in. Because that means that if you've gone past that point, if you're sort of not that close to the point, but you've gone sort of past it, you might want to switch as well. But yeah, I can put that in later. Close enough to switch points. So basically, like if let's see, self dot target point index plus equals 1. So we move 1 point backwards. If self dot target point index equals self dot transform buffer get count, that would mean that we have reached the last point, and we quite simply want to set active false, right? There's no point in going any further because we don't know where to go. Does that make sense? I think it makes sense. But we can print stuff here to help us actually develop this thing. Switch to target point index something. Right, and I'm gonna make it very clear here what's going on. So reached the last point. I like being very explicit with my prints when trying out these things for the very first time, because quite often you write something like this and then it just goes into some like infinite loop somewhere, and you're like, oh, okay, I know what's going on. So this looks good. Okay, so now we're changing the points. We're moving along that path that we had recorded. Of course, we need to apply the force there to actually make it happen. So we basically want to do this, but we don't want to get the distance squared. We just want to get the length right. Oh no, we don't actually need the distance at all, I think. Let's look at the spec again. So we're trying to figure out how much force we actually want to apply here. Let's see. The system is enabled, doesn't record any new points. It selects the target point, yes. It starts at the most recent point. The vehicle is close enough to it selects the next, yes. Alright, so we're here. If the vehicle has no recorded points, so the vehicle is close enough to the last point, system deactivated. That's done as well. This one is not done yet. The magnitude of the force is proportional to the linear velocity of the vehicle. Yes. Right, so we need the linear velocity, not actually the distance. But we do need this target transform to figure out where to actually go, in which direction. But we need this physics actor. And I'm thinking maybe we can actually just get that guy. And keep him around. Keep them around. So that we don't need to go through the whole getting of it every time we update this thing. So let's do that, and let's actually just put it here. Shorten it a little bit. Physics actor pointer. So physics actor, and it's null by default. So this thing looks a little weird, perhaps, if you're used to the way that Zig does its types. This is a pointer, as can be seen by this PTR here in the type. And it is not like an actual Zig pointer, like that would be a Zig pointer, but this is a pointer to a C++ type. That's why it has the pointer here in the name. And we can actually set it to null here. What's up, Matt? Welcome back. So we can get this guy here in the self dot physics actor equals self dot context dot transform get physics actor is right there, and we can assert that it's not null, like right here. Again, we can do an s assert self. We don't like, yeah. We don't want it to be is null, like so. So these onObject createds are called in, oh, I don't want to start the editor right now. These guys are called in the order they are actually listed here. And so because the first component this thing has is a dynamic body transform component that this guy creates the actor. So it will be created by the time we get to the unstuckifier. Hey Tutu, everyone is showing up all of a sudden. Nice to have you guys here once more. So now we can get rid of this. Where did I have it? Right here. Physics actor, and we can just do self dot underscore physics actor. And we want to get the linear velocity, yes. And we most likely don't want to get it squared. Right, so linvel, no squared. Thank you very much. Let's look at the spec again. So when the linear velocity of the vehicle is 0, the max force is applied. And when the linear velocity of the vehicle is some target value, so that would be like this target linear velocity that we set to 3 there, then no force is applied. Yes. So let's do like force is, and we can do a remap. So let's do like basis math, remap float. We'll do linvel. So when linear velocity is 0, we do the max force, and when it is the BP props, we need to get the BP props. Let's get the BP props. Actually only need it if the thing is active. when the linear velocity is the target linear velocity, then we don't do any force. So this will be sort of the opposite. We do max force and then we do 0. Right? That's the force. I sound chirpy. I hope that's a good thing. I hope that doesn't mean like my audio equipment is breaking down or something. Right. The force is a vector though, so we need to do like and then hey, what's the white background window that you pulled up a few times? You mean this guy? If you mean this guy, it's checklist. It's an outliner. It's just well, it's an outliner. You can do like hello thing 1, thing 2, and then you can assign things and you can like give them colors and all kinds of things, and you can like Jesus, I this thing has like so many freaking features. Oh, not this one. Okay. Oh, you mean the asset browser? You mean this thing? If you mean this thing, this is the asset browser. So this is like where you design the game object types. So they're called blueprints. They've been called blueprints for a very long time. At some point, I realized that Unreal actually uses blueprints as well as a term. But yeah, blueprints is just like it is just basically a list of components. So we're working on this Scout vehicle now, and it has like a bunch of components that you can see here, and it's actually quite a long list. But yeah, you have like different vehicles here. I have some like trucks, yeah, and yeah, none of the vehicles have wheels here. But you can see all of their components here, and I have like, you know, there's a stump, here's a rock, here's a spruce, and you see all of their components here. So this guy has like static body with a collision here. You can see the collisions, and it has a mesh, which is the trunk mesh, and you can sort of see the difference here in the preview as you're making these changes. So basically just designing object types. They're kind of like prefabs in like Unity, but not really. And yeah, there's not the asset server, as Matt mentioned. This is the asset server. So this is just a thing that like converts stuff. But yes, it's just it's basically like where we, in this very specific case, if we go back to the Scout, we have this unstuckifier component in the list here, and these are the values that we set for this particular blueprint. So if you're working on another vehicle, you might need that vehicle to have the same component, but you need different values for it here. So you can just set it on like a sort of a game object type basis, and then you get to read them from this blueprint properties object. Right. So the force is a vector, and this is now a float. So basically what we need to do is get a force direction. So force direction would be target transform dot position minus self context transform get position. And like I I think I had in my spec there that we want to actually apply it on the center of mass. That's not actually going to be the case now. This is the pivot of the object, so it might be a little wonky, but we'll see. I'll probably have to define some position in local space for the vehicle where we actually apply these things and where we compare all the distances and all of that. But we need a normalized vector, so that's the force direction. And this would be something like the force magnitude, right? Something like that. And then the force itself would be force direction multiply float force magnitude. Right. And I think that's it. I think now we should be able to try this out. So physics actor apply. No? Oh, add force. That's what it's called. Apply force. Add force. So the force is force, of course. And the position is now that, like, this is the interesting part. We would actually want to apply this at the center of mass. I feel like I probably actually have to do that still today, because this is most likely going to be kind of wonky. What was that actually? Oh, right, okay. So we want the position, we can use the thing there. We also want to apply this thing at the position. And sure, we can wake up the actor if it's sleeping for some reason. And let's print this force magnitude here as well. Force applied. Let's do like D.2 maybe. Force magnitude. Let's see what happens. Right, it's in use by this guy. My Spidey sense tells me that this max force is going to be way too low though, so let's add up that to like 50. I don't remember the actual unit for that. It's like the physics. Well, it's piped through to physics, so it's probably something like, I don't know, newtons per square. I don't know, square meter or something like that. But okay, now if we're driving slow enough and I press U, I should like be sort of pushed back. Let's see. Right, so we're applying force. It's not really doing anything. That's fine. Deactivating it. Let's just up that value quite a lot. Let's up it to 500 instead. And you might have been able to see there that as the vehicle was coming to a halt, the force actually increased. Let's see. Yeah, still not really doing anything. Let's see. We're applying the force in pre-tick. That should be quite all right. Just up that like a whole lot. Let's just put it like 50,000, and then ideally the car should like go flying. Yep, we're going backwards now. Alright, so You can see that we were way off on that force magnitude scale there. Right, so now we're doing like 5,000, and that has us basically rolling across the plane here. What will happen now when we actually get to this part here? Yeah, you can see that now we're not actually I'm not touching any controls now, by the way. Now it's kind of like pushing me along that. So ideally we would actually apply some torque as well, right? Oh no, what happened? What happened? Switch to target point index 27. Oh. Right, we actually probably have some bug here in the let's see, in this code. So I probably actually got to the last point. If target point index is this, so I bet we actually had like 27 points, right? Yeah, so that needs to be like -1. Is that right? That doesn't feel right. Like this should now be... Yeah, that is right. That is correct. In pre-tick and a few other functions, most of the body is in the if self-active conditional block. Is there a reason not doing an early return? No, not really. Not really. I mean, here, for example, here we have like an active, and then we have a deactivated block here. We're recording points where we're not active. We're applying forces, or actually we're checking the target distances when we are active. I guess here we could just do self.active return like that. But no, not really any reason, except I kind of need to do some things in some of these, like whether it's active or not, so I just did the same thing. Alright. Right. Let's do something a bit more crazy now. Let's like drive off a small cliff like this and see what happens. I'm sort of fully expecting this to... Ah, okay. Hey, look at this. Right, now this is exactly the kind of case that the system is supposed to actually fix for us. And look at that. And then, isn't that cool? That's pretty cool. That's pretty cool, you guys. Let's try to get stuck in some other places. I do want the outputs though, to make it easier to see what's going on. Like I bet we can actually get... there we go. No. Okay. Well, this is the thing. When you want to get stuck, you kind of don't get stuck, right? That's how it is. But let's pretend I am stuck now. Just press U and you get kind of nicely yanked off the thing. Oh, right. I probably have some bug here with these indices still. Switch to target point index 7 and integer overflow. So current back index minus offset. Yeah. That's not good. Is that what? That's 0? Let's do self target point index 7, and in it we have how many? Why have we not actually deactivated the thing here? It's interesting. Do I just have some stupid mistake here? Like this makes perfect sense. Like the current back index is 6, and we're giving it an offset of 7. So that would make it yeah. Yeah, see, this is just straight up ported from C++ version, and I bet I actually used signed indices there. Let's have a look. Yeah, I used integers. And here I use probably like U sizes. Yeah. Okay. I can change these to I32s if I want to. Yeah, it's an integer overflow because I use unsigned integers here, so it just it wraps around and becomes really, really large, while this C++ version here actually just uses ints. So it has like this. Nah, this is kind of stupid. Perhaps I could do like a modulo thing here. It's like really, really old code. It's probably like 10 years old code that I just ported over to Zig at some point. But yeah, this works because it's an integer, but it doesn't work because it's a U size, right? So that's why. But yeah, you can do like would be like I32, and then do that. That would be like a int cast. Oh. This is nasty. I32. Something like that. Back offset, that's the same thing with a minus instead. Something like that, maybe. And that can be an int cast. Yeah, I should probably actually rewrite this thing at some point. Let's see, it's probably gonna complain about some types. Yeah, exactly. Yeah, this type is really just straight up ported from C++. Most likely like copy pasted even, so it won't be very nice and Zig idiomatic. Mm-hmm. Come on. Yeah. So many places with this. this cast now becomes an issue. I changed those to signs. I want the interface to be usize, but I should just rewrite this to use just usizes all over the place. But I don't want to do that now. I'm not working on tech today, unless I really need to. All right. So that should make it not crash. So basically I should be able to have a very straight line here and just do a U, and it should like revert along that whole thing and then come to the end, and then it should deactivate itself, right? I guess I can even I can even actually steer this vehicle here. Oh. Let's see. Switch to target point index 1. Yeah, actually, what we want to do here is basically this, right? If we have reached the point, damn, off by 1 values, or off by 1 bugs. I'm sorry, my brain is hurting. If we have 4 points and we reach index 4, that means that we just actually switched past the last point, right? And that means that we need to deactivate it. Yeah, so it shouldn't have the -1 there. My brain is hurting. But that's good. Yeah, let's see how it handles some more tricky cases. Some more tricky cases. I like how we're bike shedding this unstuckifier a little. Yeah, well, that is what sometimes happens. So where do we want to get stuck? Oh, I know where we want to get stuck. We want to get stuck on top of a box or something. This might just explode now. Let's see. Yeah, woo! Okay, that's it's kind of stupid. Does the thing actually handle this sort of movement? Let's see. Press U. Yeah, it can't quite lift the thing. Yeah, okay, thank you. That's quite enough of that. But yeah, you can quite easily get stuck on like boxes and things. So let's see what happens if we actually do that. Yeah, this is mostly like a tech sort of exploration still. Before this is like an actual gameplay feature, we need to sort of see how the physics engine and all of that handles this sort of thing. And then I need to come up with some solid rules for like, hey, when are we actually allowed to, you know, activate this thing? And then we can use, then the sort of actual gameplay feature can then, you know, use this unstuckifier to do things. Right, so now we're stuck. Not really. But it does happen that you get stuck, so now it just sort of rewinds it. That's nice. Okay. Can I get good and stuck? I'm pretty stuck now. Not like not really all that stuck, but still a little stuck. What? Where's it going now? Let's actually let's like draw the force direction of this guy. That seems like a good idea. Force direction. Like 3. We can make that 0 for now. So self.force dir is that, and that makes sense. That doesn't need to have a const. And in update, you know, if self active, then how do we do this? Probably need the position. Like this is the start of the thing. That would be like P0. Then we have P1. Would be P0 add self force dir multiplied by, I don't know, 3 or something to make sure it's visible enough, and then we do basis debug draw line 3D. Oh, P1, P2. All right. Well, we have P0 and P1. Let's do color like basis color yellow or something. We could try to get stuck on the big elevator flappy door thingy, yeah. Yeah. The big elevator flappy door thingy, the problem with that though is that when it actually, you're talking about the elevator ramp, and there's also a similar thing on the monorail. The problem with that is that when that thing rises, the elevator and or the monorail are actually like in motion, so it's gonna get very confusing. Right, so there's the direction. The direction doesn't seem to be wholly correct. Let's do another thing here. Let's do. Right, we're drawing this with a 0.5 and white, so let's do basis debug draw. Basically, we want exactly this thing, and we don't want it actually inside the for loop. We want it after this, and we want it only during the active phase. Front offset. Right, we actually, the index is using the back offset. That's that thing, so we want the active position. Right. Draw sphere back, and then we want to draw it with like a larger radius and probably like an orange sphere. That sounded like an excuse, yes. I mean, sure, I can show you what happens. Let's see. But it won't it won't be pretty. Is what I'm telling you. So basically, you want to do this. You want to put a scout like here. Let's make that the avatar. And then like maybe back it into somewhere here. And then we can start the elevator, which makes the ramp like go up. And right now we're good and stuck. But now the elevator starts to rise. So now we can do like unstuckifier, and it will sort of, yeah. It now tries to get us like downwards, but it can't do that. And there we can see the active sphere. So yeah, it kind of doesn't really. I'll just delete that guy. Oop. It doesn't really work in that sense. Oh, I think I know actually why this thing doesn't work, right? Oh no, it should actually be fine. Oh. That's a problem at least. Yeah, okay, so the selection is not good of the target. Target selection is not good. Like if we try to, I can sort of drive here. It's super wonky now because it's like applying the force while I am driving, but yeah, it shouldn't be selecting that. So let's see what's going on. It's in the tick one, right? Can we actually see this switch the target point something or other? If we just do this very simple thing, just drive here, activate the system, and like, ooh, that's what happens when you do handbrake, and then try to get unstuck. Let's see, does it actually switch to activate the unstuckifier? Yeah, it hasn't switched to anything. So back offset. Remind me again. The back is the newest element added to the list. Back offset 0 should be that should be the most recent one, right? That's probably not correct. I mean, this ring buffer is used like all over the place in the actual engine, so I have a feeling that this one probably works. That's an I-32. That's also an I-32. Okay. Oh, right. There's the bug. Yeah, that's supposed to be back offset. Current back index, not offset. There we go. Let's view this in the freaking the diff of the thing to make sure I didn't do anything stupid. Yeah. Yep. That looks good. That looks good. That should work. That should work. Now it should work. Now it should work. So now if we do U... Oh, we need to slow down first. Yeah, now it's working. Yeah, that looks like a good thing. Let's see how that now behaves with like an actual case where you get stuck. This was a pretty nice test case here. This little edge, something like this. And you're like, oh no, I'm so stuck. Press U, and it just gets out of there like a champ. Yeah, it's sort of just moseying along that path now. I'm not touching any controls. It's just like nudging it along. Ah, that's fun. Okay, good. Good. Let's try something else. I think, like, in my experience, actually, this particular car doesn't get stuck all that easily, but the gripper gets stuck like all the time. So I think what we should really do here is add this system to the gripper and see how that behaves. So let's do that. Right, so what do we have? We have like 50,000. We have 1, 3, 50,000, and 5. Let's use those same values for the gripper. Unstuckify. We do consider having four-wheel drive on any of the vehicles, so some are better at steep traversal. They are basically all of them four-wheel drive vehicles. Yeah. I mean, it doesn't look like that all the time. 1, 3, 50,000 and 5. 1, 3, 50,000 and 5. Yeah, it doesn't look like that all the time, and that has to do basically with the differential used. So this one uses a limited slip differential, which is like an actual thing in cars. And what that does is that it yeah, let's see if I can get stuck on that edge again. It's typically a pretty easy way to get stuck. So I'm not sure if you how well you are versed in how differentials work in like actual cars, but the idea is that the differential tries to get well, first of all, it makes cornering possible without like wheels sort of jumping around wildly, because like wheels during cornering, the wheels actually travel like not the same distance. So here, for example, and this is what actually happens with an actual real car with like a limited slip differential. If you drive your car into like a ditch and like one of the wheels actually end up in the air, and you press the the accelerator, that wheel that is in the air is typically the one that will start rotating. Limited slip differentials try to avoid that a little bit by basically figuring out, okay, is there like actual traction on any of the wheels. You can see that like some of the or basically all of the wheels, when I press the accelerator, they do rotate, but there's so much more friction on these wheels compared to the one that is like in the air that it just rotates like very, very, very quickly, even though there's like actual much more torque being applied to those other wheels that are actually have some traction. So now we can try to unstuckify it, and it, oh yeah, I need to like disengage the handbrake when this thing. Yeah, there's like an automatic handbrake in the vehicle SDK that actually sort of handles that. Yeah, this is kind of handy now because I can just, take that away. So that's like, this is just like the stock PhysX limited slip differential. You can actually go have a look here on the Madrigal Games website. I wrote an article, or a blog post I should say, about, so we have this 6-wheel drive vehicles in PhysX. So out of the box, PhysX gives you only one differential if you have like an N-wheel vehicle. But the problem is this, that the torque is divided equally among all the wheels. So if you have 2 wheels here that are like stuck in the air, you have basically like this problem. Can I get like a slightly better video here? You can see here that like I can't even get up of this very little sort of bump, because like these wheels that are in the air sort of eat up almost all of the power. So I created something that I call torque, or it's not me that's calling it. It's an actual thing, like in real vehicles as well. System called torque vectoring, which is like you apply torque to the wheels that actually again have traction. But this thing is actually not available in PhysX by default. So I created a differential for this, and with the torque vectoring on, you can see that it just handles this bump very easily. Even though some of those wheels are in the air like this, you don't really get stuck at all anymore. And that thing is now used by all the like 6 or 8 wheel vehicles. So the mother vehicle, for example, uses this, and it's basically like this is the whole thing of the code. I essentially check which one of the wheels have the most spring force in the suspension. So essentially, like the wheels that are suspended in the air, they get almost no torque, and the ones that are compressed, they have the suspension compressed, they get much more. So that's why sometimes you see the mother vehicle have like a single wheel that is very, very much compressed, like spin very, very fast, and the other ones are almost completely still, and that's just because like the torque vectoring detects that, okay, this wheel has the most like potential for like having traction, so the force is directed there. It gets a little complicated. In some games like Mud Runner or Spin Tires or whatever it's called now, Snow Runners, you have the option to like disable the differential completely, and that's, as far as I know, that's also like available in like actual vehicles in real life if you're working with like I don't know, like a truck or something. And at least in Mud Runners, the differential sort of kind of get like it damages the vehicle a little bit if you drive around with like differential lock on for a long time. So I guess that tries to simulate like real life conditions. But that way you get basically the same. You lock the wheels so that they rotate at the same speed, all of them, regardless of like how many wheels you have on your vehicle, and that can get you out of like, you know, mud pits and things like that. So maybe that is something that I should put in here as well, if we get really sort of crazy and technical with this. Yeah, I can typically get away. What was I gonna do? I was gonna do the gripper, right? This is just fun to play around with, though, to be honest. Right, so gripper now has an unstockifier. Let's save this and relaunch the game. I don't know if I did that already, but I got kind of lost in my explanation there. Oh, gripper, thank you very much. Alright, so now the gripper also draws these spheres for us. Fair play, now I know much more about vehicle transmission. Yeah, like take everything I say about this with the grain of salt. I'm not by no means an expert. I know just enough about it to you know, be able to use the vehicle SDK in physics. I would not know about these things if I hadn't. If I wasn't trying to make this game, basically, I wouldn't know about these things. So I know just enough about them to be able to do this. So it's possible that I have something wrong. All right, so this is the now you can see, like, I immediately got stuck, and I'm trying to reverse and nothing happens. The wheels on this car are not as detailed as on the Scout, but I am trying to reverse away, and it doesn't allow me to do that. So now I can just press U, and something is happening. Oh, I'm still probably right. Okay, yeah. So we have the same problem again. If I leave this vehicle here for a little while and basically let the physics system come to a rest, and then I press U, we are again fighting the handbrake. Right, so basically what I probably want to do here instead is this: get stuck here, and then I reverse like a little bit and then press U, and now then it immediately works. So, oh, what's happening? All right, yeah. It went back and forth, and it did that because I just kept going back and forth there. Yeah, it's a little stupid. It's a little stupid. I should probably only add a point to this if if it's like far enough from any of the previous points in there. And what I actually realized now, you can see we have double spheres here. What's that about? Well, we probably have it on both the client and server here on the gripper now. Yes, let's take the client one away. I mean, it doesn't really get to do anything because the server keeps overriding it all the time, but it still like makes the debug rendering confusing. Break out the old dot product. Well, Yeah, I think actually what we want to do here is just like, I mean, angle is one thing. Yeah, you could measure the angle to the previous point, right? And then you could, you know, see if it sort of goes back and forth. But that would probably not handle all the cases where you know the player does something similar to what I just did there, where I go like back and forth, back and forth, back and forth. It would skip some of those points. I think the easier way is just to have it compare against all the points that we currently have in the buffer, and if they are close enough to any of the previous points, we quite simply don't add it to the buffer. That might be easier. I probably won't have like 32 points as I have currently anyway. I probably will have like 16 or 8 or something. And I think the distance between them is probably going to be a bit larger as well. But we'll see how that actually works out. I think there's like a place up here that you can get stuck on kind of easily. Let's put another one down. Yeah, differentials are they're really nice to learn about with Legos. Lego differential gear. You know, this thing that's a differential right there. That's an open differential. That means that like if you have one wheel that is that has traction and another one which doesn't, then basically the one that doesn't have traction, the one that's in the air or you know like on ice or something, where it just spins very easily, and the other one doesn't, then all of the power will go to the one that spins easily. But you can just get one of these guys and like play around with it, and it's kind of cool how differentials work. But yeah, an open differential is it's almost completely unusable for like an actual car because you don't want it to be sort of that free and open. And this place is annoying because it's tricky to see what you're doing with the camera getting blocked by this overhead thing. So I probably need to redesign this somehow. Yeah. Yoink. This is typical place where you get stuck. You're like, oh no, and I'm stuck. Except I don't get stuck now because of the demo effect, apparently. But yeah, let's just do like something kind of crazy here and just do something like this and go like, oh no. All right, Unstuckifier, do your thing. It's almost as if like you had a winch and you just attached it somewhere, and then you're just like driving that winch, and it would get you out of there. That's really cool, actually. I like this. I like this thing. And then you get to actually steer. Maybe I should sort of explain this to yeah, look at that. Now I'm stuck. Hey. Now I'm like properly stuck. Unstuckifier, thank you. A little bit more. And the problem is that now I don't have any points to unstuckify myself along. Or do I? Yeah, like I don't now we want to go down there again. Alright. Let's see what happens. Yeah, and the power cell, even though it's like technically attached to that thing, it's sort of wobbling around a little bit because it's attached to the server. Yeah, so there's some issues to iron out still. Oh no. Oh no, help me. Some like decisions about like when to clear that buffer and when to not do that. Yeah, space them out, absolutely. Yes, like I mentioned previously, we can just do that right now. It's right here in the blueprint. This should probably be something like 3. Let's try 3 and see where that takes us. Let's make it 3 there as well. I wonder if we should try to just make this max force even larger. Would that hurt anyone? I don't think. Yeah, I mean, I was kind of thinking about like not even bothering with like explaining in universe how this system works. It's just like no, it's a game. You get stuck, you press this thing, and you get unstuck. It's fine. Don't worry about it. But it would be kind of cool if you could just like explain it with like no, it's a winch, and it you know attaches itself to something. We could even sort of semi-intelligently just draw some sort of winch cable somewhere, and like the rough direction of where you actually need to be going. Can this thing just hoist my vehicle up there? Because it's kind of cool. You can help it out a little bit. Oh no, more power. Come on, let's go. Let's go. Yeah, up. Yeah, and of course it doesn't go back to like the previous point either. It's just wobbling. Wobble, wobble. Wobble, wobble. Alright. Yeah, I need to think about this. I mean, the most important thing that I want to accomplish with this system, it seems to already handle. So basically these things where you just like, you get annoyingly stuck in some small, you know, little pit somewhere, and you're just like, oh my god, I can't believe I'm stuck here. This is bullshit. Those kinds of things, it's already handling like really well, and so that makes me happy. It's not really supposed to handle that sort of thing. You're just driving off a cliff, and you're like, no, I need to get back up there. That's like a gameplay decision that you made to drive off the cliff. But yeah, just like driving near a rock and getting stuck on the rock and just being like, what is this? What is this game? Screw you, game. that sort of thing. It needs to, like this thing here, and you just press like U, and then it wobbles off the rock. Yeah. Maybe need a reset. I probably need a reset. Yeah, moving back to the last road is something that could easily be done. I mean, you can just teleport an object and it will handle it properly. It doesn't necessarily work from a gameplay perspective though, because if you have well, I don't really have it here in the demo, but if we have this thing here, right? We have like a crate there and like a, I don't know, like a power cell. You know, this thing here, and then you get stuck. Then you get stuck on a rock, and then if you teleport back to that thing, then either you need to, well, what you can do is you can get the relative transform of those items, those cargo items, and teleport them back. That is possible, so that they would sort of stay in the car. That means that you need to sort of keep track of the state of each dynamic object though. Is this in the back of this car, you know? And if you have a bunch of them, if you have like a do another power cell there, and okay, stop, come on, stop moving. Debug box, right? If you have this case, I know it's a little contrived, but you know, humor me for a bit. Would this box now be considered to be in the back of the car? I don't know. Maybe it would. If you had like a trigger that moved, a trigger volume that moved along with this vehicle, then maybe it would be covered by that trigger volume. But you know, if if it's not inside the trigger volume and you teleport back, then that would teleport back all the other objects because they're like lower down. But this box right there would be left out, and they would go like, what the hell? Why did that box not, you know, come with it? So that's why I like the thing that just like sort of pulls at your vehicle a little bit. And yeah, the box might fall off, but that's then just sort of like it's explained just by the fact that, hey, you got stuck, you had to get unstuck, and during that the box fell off. I kind of like that explanation better than just like, oh, we had this magical thing here where we skipped forward in time to where you were back on the road, but we just left half your stuff behind, you know. Oh. What's the UI gonna look like for the winch thing? So the winch thing is just something that I kind of came up with during the stream. I didn't really have a plan for it. So the winch thing, as I was sort of thinking out loud during this stream, would just be basically, if we have a, let's get a scout going here because it's just the easiest to drive with this guy. If we have this guy here, and then we get stuck on like that rock over there, if we can manage to make that happen. Let's say we are stuck here now, and I can't move, right? If we now press U, you can see the right. All right, like so. Now it's doing what I want. So now if we are stuck like this, and you come from over there, the winch would be sort of automatic in the sense that, you know, it's figuring these things out, these positions out, and it knows that okay, it's actually like pulling you in that direction, right? So I don't know if you really need a UI for the winch. You would just sort of just, you know, figure out some place here where you were, and just draw like a cable that is like temporarily, you know, attached to the ground or whatever, to some like static object there. Probably like some like physics surface is probably the easiest to attach it to. But it would be sort of automatic in the sense, if we're thinking about it just in the terms of, you know, what I talked about today. That would be kind of cool, because then you would just sort of go like, I am stuck, I want my winch, and then you press the winch key and it sort of pulls you in the direction you came from, right? That would be nice. That would be sort of minimal. But yeah, the whole idea of a winch is just something that I sort of came up with, or I guess someone else might have actually mentioned it in the chat before I mentioned winch today. But it's just something that we came up with during the stream, that hey, maybe this could actually be like a winch, and that is how it could be explained sort of in universe. But I'm not sure I'm gonna do that. The most important thing still is that we can get unstuck now. Or not maybe quite yet, but showing promise already. Yeah, driving with this, like with things in the in the back, it's kind of tricky. It works pretty well at low speeds, but then it just starts sliding like crazy when you go high speeds. I don't know why exactly. Those things are pretty heavy. Yeah. Let's play around with these values a little bit still. So I think target linear velocity we need to allow it to be a little higher. Let's be like 8. And then max force, let's double it even more. I just want to see where this thing sort of goes completely bananas. And what sort of values we can reasonably expect to play around with here. And then maybe let's just drive up some cliff somewhere. So and now it's very clearly sort of it's very clearly bringing you in the direction that you kind of want to go. Yeah. All right, that's enough. I'm unstuck now. Ugh. Alright. Can I go flying now? Do I have enough power to go flying? I kind of do, but not quite. Yeah, this is the problem with the with having it proportional to the linear velocity, because like when you move fast enough, it just stops applying the input. Which is, I mean, it's perfectly fine for getting unstuck. It's just like, it's not a rewinding system. It's not something that, well, as you can see, really lets you go flying. So it quite often it kind of just loses power because like you're going too fast, you're not going exactly in the direction that you need to go. You're still going pretty fast. It just stops applying input or like force to it. Yeah. I think we want to have the max force just really quite high. But we specifically want the target velocity to be fairly low after all. I mean, you don't need to get unstuck quickly or with like in like a high speed. Indeed, you probably don't want that. But you do want to get unstuck. So if it looks like you're not gonna get moving, then you need to have that max force there to actually make that a thing. But just sort of not have it done very quickly. And this sort of thing, it's handling it really well actually. I mean, it's now I can just drive along this thing, try to get off to the side, and it's like there's no force applied because I'm going too fast. Yeah, this needs like playing around with a lot to see what is actually sort of what is actually a good thing. I think this thing here, this point switch distance, that probably actually needs to depend on the distance between the points, right? So let's actually calculate this guy. The point switch distance is like BP props recorded point distance, maybe half of that. Yeah, I'm a little bit with Matt on the thing that like let's not over explain things. We're already not explaining how we have a bunch of people in the story, in the narrative. We have a bunch of people, like 6 or 7 people here in this sort of group of people that the player is part of. And those people have a few vehicles, but we're not explaining how like they're never seen outside of their vehicles, right? You can just go like, hey, come here, mother vehicle or scout or whatever, and one of those people will answer, and we're not really sort of exploring, oh, how did this person switch from this vehicle to this other vehicle, you know. If you go down that path of you know explaining all that stuff, then you quite quickly find yourself in a situation where you need to explain like a whole lot of stuff that you don't really want to necessarily care about, because it's not really helpful or doesn't make the game any better, basically. Yeah, I think this switch distance might be better. Getting stuck here. Up. Let's say I was stuck, and it just yoink. It would be nice if it could sort of detect when to stop when to deactivate the unstuckifier. It's quite often it's quite quickly after, you know, after getting moving. It's like, okay, that's enough, and then you can. Yeah, and this place, for example, that we shouldn't probably have done that. We shouldn't have actually like gone up there and then back. Yeah, so that thing would have been solved by just comparing against the previous points and going like, nope, this thing is too close to some of the previous points. I'm not gonna put it into the buffer. So that we don't go back and forth unnecessarily. It's like there's no point in doing that at all. Like I mentioned in the beginning of the stream, like Halo is definitely like an inspiration for this game, but so is the Spin Tires and Mud Runner, all of that series, right? And that series also doesn't explain like how those people actually make things happen. If you have a winch, you just like you click somewhere and there's like a winch that's magically attached to a tree, and when logs are put inside of a trailer, they're just gonna magically appear there. Sometimes you lift them there using some sort of tractor or something, but there are no like people around, and it's just like no one cares. That's never heard anyone complain about that. That oh why where are all the people? The game is just not about that sort of thing, and I wanna limit the scope of what I actually explain here, because I mean this is still a sci-fi world. There's some sci-fi stuff going on here, even though I haven't shown a lot of it, but it's planned. There's planned to be some weird sci-fi stuff. And I don't plan on necessarily explaining that either, all that thoroughly. Right, this stream is just all about driving up onto rocks and then getting unstuck. Yeah, the Souls games they do narrative in an interesting way. I'm not very I don't know really anything about it, except that there is a lot of narrative there, and you kind of have to go digging for it if you want to know, and it's not like spelled out for you. That's definitely an interesting way to do it. It's also like production-wise a pretty or it can be. Again, I shouldn't say because I haven't played many Souls-like games, but it can be like production-wise a pretty cheap way of doing narrative. If you have like a person or a few people on the team who are really good writers, you just have them write a lot of stuff, and then maybe some level designers doing some like environmental storytelling and things like that. But if you don't have like a whole lot of voice-acted dialogue and things like that, then it can be a pretty cost-effective is the term I'm looking for. Cost-effective way of doing narrative. All right, this is pretty good. Yep, you can do things like that, and you can just get like you can get unstuck, but you can get unstuck like on your roof, things like that. That's again is one of those things that I don't want to have to explain all that much. Why the car didn't brake when it went onto the roof? Like, I don't think anyone cares. I don't want to do any damage model or anything like that in the game either, so yeah. I have a feeling that this is something that you will hold the button and you will get unstuck, and then when you let go it stops the rewinding. I think that's probably going to be best. So what I'm probably going to do, and this might change, of course. I might come up with some brilliant idea of how I want this thing to work. But what I probably will do now, like starting probably tomorrow, is do like a minimum viable version. Oh, test mission, no. Remove smokestack, thank you very much. Do like a minimum viable version where you can quite simply enable this thing. Look at this. I'm just good and stuck. I can't do anything. This is something that's super annoying with this ramp. You just get stuck on this really easily. So now I can just do whoop. Look at that. Isn't that nice? No getting stuck anymore. But yeah, do a minimum viable version where you can quite simply just use this thing. It is available to you, and you can probably do some pretty weird stunts with it, just for a little while. And then I will let people play the demo, and we'll see how it is actually being used, if it can be abused. The most important thing is that people don't get annoyed at being stuck in some stupid little pit somewhere when they were just about to do something cool. And not really worry about like, how is the vehicle getting stuck? Where is the winch? What are the implications? Just like go like, no, I'm not caring about that right now. Let's see if we can get stuck again. Can I get stuck again? I can. This is like infamous, this railing here. It actually kind of looks like I need quite a few of these points in some of these cases. Yeah. Now this is good. I like this already. I like it already. It was kind of simple to do after all. It still needs some work for sure, but yeah, I like it. And yeah, we have some newly decorated areas here, as you can see. Not sure if I'm shown any of this on stream. This area, I'm sure I haven't shown on stream because I decorated this today. But yeah, we basically only have that place now undecorated, and then we have the two sort of human settlements here. I wonder if you can grind the rail all the way down here. Yeah, I was wondering that myself. I think probably not, but I'm not sure. Yeah, that would be an achievement. Absolutely. Yeah. Part of me is a little sad, though, that there is one particular sort of I don't know, piece of emergent gameplay, if you will, that sort of is nullified by this, where if you have this vehicle and you get stuck somewhere, what you've been able to do in the mission, at least, where you can use the radio, is to call for the mother vehicle to come and help you. And typically, well, at least if you're in a place where the mother vehicle can actually get to you, they get pretty close. They typically get close enough, or they often get close enough that you can just switch to the mother vehicle, and then you can either like nudge the vehicle out of getting stuck, or you can just lift it with the cargo crane. And of course you can still do that. That's nothing prevents you from doing that, but I doubt people will do that if they have this unstuckifier to use instead. So yeah, we'll see. We shall see. Yeah, if you're wondering what that marker is there, it is the objective marker that hasn't been used except for the test mission, which I accidentally enabled from that debug menu. I don't think you can actually even get to that anymore. Yeah, I decided at some point that I probably don't actually want that. You can set it on a game object and it will follow the game object and just show you where to go. But I think I won't necessarily want that. I think it might be easier or like nicer design to actually just... Oh, you can actually go here because we don't have the main mission. Yeah, so we don't have any blockers here. Yeah, this was a test mission. It's just like it tracks that object. Yay! I found the place. Oh, and look at that. Now we're stuck. Like that is exactly the sort of annoying thing. You're like driving, nudging one of these boxes, and then you somehow end up on top of it. This is ridiculous. Like now here you can see the four-wheel drive of the vehicle in all of its full glory. But yeah, this sort of thing has happened on multiple occasions. I can just press U, and you get off the thing. Ah, so nice. It's like a weight off my shoulders to see this system working this well. Awesome. But yeah, I was about to say that I sort of decided, at least for now, that I don't want those mission objectives, because it's actually a reasonably big part of this game is just to like drive around and discover things. If you have mission markers in this, it's just going to be like a very simple little thing to play through it. And let's not have that. But maybe if you get super stuck on a mission and like haven't done anything for like 10 minutes, then maybe one of the characters will go like, go here, do that, as an accessibility thing. All right. Yeah, I think I'm probably gonna end reasonably soon. The system works already kind of well, and I need to have a think about how I actually want to take this further. I have some ideas already. But I think this is basically it for this time around. We can maybe for just as a test add this thing to the mother vehicle, and then play a little bit of the main mission. So let's do 3.8. What is that? 200,000. What was that? 3.8. 200,000. Yeah, the radio call is not a bad idea. The problem with that, if you want to call it a problem, is that you would most likely have to have like a distinct radio call for most of the things, right? If you are that looks stupid in the intro cinematic with those spheres there. Well, if you have a well, in this mission, for example, you need to find like the gripper, right? And you find the gripper in some certain place. So if you're just driving around and you don't know where to go, then a radio call that tells you, hey, you can find the gripper in this and this place, is of course like a distinct thing. But if you have that marker can just be placed on any game object or any world position, I guess. And that means that you can then just have a number, a few different radio messages that can be like sort of like, oh, okay, you need to go here, you know, this is the general area where you would want to go, and then you can place it like somewhere kind of close to the target, or just directly on it. And again, I forgot to turn off that thing for the client. There we go. So this thing can be actually, we can set it here that it doesn't support clients. And now it's going to be, if we reload this UI component definition and then just go here and look at this, it should be grayed out. Boop. Yeah, that was grayed out. Right, yeah, now of course it always just goes into the raw level without any mission. Let's just try out this unstuckifier with the mother a little bit, and then call it a day. See how it works. It might be that the force is just way too small, but then again, it is, the max force is pretty high, so we'll see. We'll see. All right. This is nice. There's like, this is like two of my sort of fears in this project have somewhat recently been not completely solved, but just like made a lot better than they were. Like one fear was how well I'm gonna get the mother vehicle AI to just navigate these places, and it's getting actually really good at it. It occasionally gets stuck, yeah, sure, but it is actually quite rare now. If you're just trying to play the game, if you're not trying to do something silly and stupid, then it's kind of rare that the mother vehicle actually gets stuck. And the driving AI overall is just like much better. That was one fear, and now this unstuckifier business is also quite nice. It's showing promise. Right, so let's see. It may be that this just now goes flying, because I'm gonna get this thing good and stuck. How do we get it stuck? Probably like, I don't know, here. Something. This is not stuck enough. This is clearly not stuck enough. And that monorail track still doesn't have any. Oh, there we can get it stuck. Yeah, that's gonna be good. That monorail track still doesn't have any collisions. I need to put those in. So this thing is probably too long to fit there. Yeah, okay. Oh, where is? Alright, now we're pretty good and stuck. Let's try to apply this. So it's applying a force. It's basically the max force, because the max force is 200,000. It's like 199,000. So you can see that, okay, that it's clearly not enough to move the needle on this guy. Okay, let's up it. Let's make it like, what is that? Is that a million? A million forces. $100 million. And yeah, I should really make this intro cinematic skippable. It's not like super easy to do though, because we're actually like moving game objects around here. I mean, I could teleport them, as we previously mentioned, but it would be nice to just be able to like fast forward the time a little bit. Right. See if I can get the mother vehicle stuck up there on the slope there, between the rock and those trees. Probably can, if I put my back into it. So that's, I think this place is roughly the correct size for this guy. Yeah, it's a little tricky to get like properly stuck, but yeah, let's press U and you can see that, oh, okay, things are happening. It does work. It's just like the force is enormous that's actually needed to move this guy, but it does work. Actually, quite well. Interesting. Yeah, you just need a lot of force to move it. It's just going like back and forth between these points. All right. Yeah, I'm gonna have a think about how I want to actually sort of package this feature. But this is good. This is good stuff. Good stuff. I like. Because this thing about getting stuck has been coming up consistently in like playthroughs of the mission lately, so this kind of solves it, at least to some degree. So nice. But yes, that's basically it. I think I'm gonna end this here. Thank you everyone who showed up again. This was fun. Thanks for hanging out. And I guess I'll see you in the next one. Have a good evening. See you later. And bye.